Alright, let's go ahead and graph f of x equals e to the negative 0.5x. And to predict tomorrow's lesson, just think about what do you think that negative sign is going to do. That just says example B. So I have 5 standard values for our table of values. I'm going to put that into our graphing calculator. Remember, E, although there are a couple of E's that students had pointed out, this is a lowercase e right here with the division sign, but that is a lowercase letter and not the number E. These are capital E's. That one's just if you're typing out words, and this one is scientific notation, so it's not that one. And if you look at next to number 4, there you have the natural base E, and its inverse, which is called the natural log. So let's go ahead and press that. It's in blue, so I'm going to press second ln. And then I'm going to type in negative 0.5x. Remember, the negative sign is not subtraction, so be careful there. Remember, we learned yesterday that E is approximately 2.71. Okay? But do not use 2.71. Just like pi, you wouldn't use 3.14. You would actually use the pi button on your calculator. Okay? So let's go to our table now. Say thank you. Is that nice? The calculator organized all of your answers for you. Now, I did see a student today type in all of this, and then they would substitute in numbers like -2, and then they would do that on the home screen, and they press enter. You can do that. But table of values is awesome. What is negative 0.5 times -2? That's essentially just 1. So you have 2.7183. You have -1, 1.6487. 0 times -0.5 is e to the 0. Anything to the 0 power is 1. And then 0.0653. And then 0.36788. Put your finger on the D value. Class, what's our D value? +0. So I have a horizontal asymptote here, which means our graph should not go in quadrants 3 or 4. The next thing I'm going to do is I'm going to pick my scale. Class, what's the largest number? What's my largest Y value? Almost 3, right? So I'm probably going to do something like this. This is what I'm choosing. 1, 2, 3. And then I'll just count by ones. X and the Y's. Let's go ahead and graph it. Now before I even graph it, you have to think back to your transformations. Again, it's a future lesson, but it's tomorrow's lesson. Think about what do you think the negative exponent would do? Look at what we expect it to look like. Right? We expect it to be an increasing function. But let's see what happens when I graph the order pairs. -2, $2.71. -2, $2, $2.50, $2.71 is close to $3. -1, $1.65. $1, $1.50. There is my very important y-intercept, 0, 1. $1.60, so 50 cents, a little bit more than 60, and then 2, less than 50 cents. And if you ever need to, you can always have more points. Let's go ahead and graph it. And there's our graph, e to the negative 0.5x. Did anyone notice what happened to that negative sign? In some ways, it's back to our transformations. We talked about letters inside the parentheses. That would be kind of like a b value. What it did is it rotated it about the y-axis. So here, this is a growth, and you're spinning it around. And now this is what happens when this is a negative.